Okay, previously we learned about pointer arithmetics. Now let's continue with this one. I'm kind of curious. What is going on with this? Because plus has a higher precedence than the reference operator. Both P and Q are increment. But because both increment operators are used as postfix and not prefix, okay. Eleven and 22. Minus I. Then it's then okay. Yep. Because you're returning A first and then incremented, but then it is in the local. Hello, welcome. We are continue taking a look at this. What is it called? Pointer arithmetics. And I'm kind of curious what this means. Okay. What written 11? Okay. But yeah, there is a big difference between postfix and prefix. Oh, okay. I mean, I've read this one before. Let me copy this in the chat. In this example, the author also using the same notation, right? Or the same expression. And well, let's check that out. The cap. And at that time, I disconstructed as this expression. Okay, so we are assigning the test. What is it called? The test value with the SCR value or the reference value, I guess, and check if the test reference value equal to null terminator. Because plus has higher precedence than asterisk, both P and K are incremented, but because both increment operators are used as postfix and not prefix, the value assigned to P is Q asterisk. The asterisk P is asterisk Q before both P and Q are increment. Before one. Okay. Alright. Okay, so because of postfix, this one, the reference P equal to the reference Q, I guess. Okay. Where is it? In C. So, okay, because of this one, the postfix one, right? I thought it become like this. The reference and increment pointer first, and then the reference and increment. The reference and increment address. Okay, wait. I'm kind of curious. Plus. What happened in here? Okay, breakpoint pointer array, okay. Breakpoint pointer array. PO. Maybe I should use this one. Okay. Alright, so in this case, with the reference first, and then I guess increment the pointer later on. Okay. Interesting. But then because we already increment this first, right? That I like. Let me maybe I should use this. To see what would happen. If we are using the, what is it called? The post-fake one. Okay. Alright. Maybe I should put Zara. In here, okay. To distinguish. And compile again. This one. Okay. I think this one should be on the same line. Right. Okay, let's continue, I guess. Or maybe which means that we derive first. No. With the reference an increment attached. An increment. Okay. With the reference and increment trace first and then increment the pointer. is reduce confusion. To the expression. Okay. Now pointers and cons. Pointers can be used to access. Alright, let me copy this in the chat in case anyone wants to see this too. Okay. Pointer. Pointer can be used to access a variable by its address, and this access may include modifying the value pointed, but it is also possible to declare pointers that can access the pointed value to read it, but not to modify it. Okay. So it's kind of read-only stuff, I guess. I can only read the pointed value but cannot modify it. For this, it is enough with qualifying the type pointed to by the pointer as constant. Okay. This one x, y, cons in pointer p, okay, equal address of y, okay. Okay, reading p, right? Modifying p, error, is cons qualified, okay. Here p points to a variable, but points to it in a cons qualified manner, meaning that it can read the value pointed, but it cannot modify the value. Okay. Note also that the expression address of y is the type of in pointer, but this is assigned to a pointer of type cons in, okay. Type cons in, this is allowed. A pointer to non-cons can be implicit to a pointer to cons, but the other way around, okay, as a safety feature, pointer to cons are not implicitly convertible to pointers to non-cons. Oh, well, let's try that out. Where is it? Okay. We already have P, right? Maybe we can do something like this. In call 69 cons in q, right, y. In x equal the reference, but doing this is not possible. Okay. Assignment of read-only location. Okay. Now let's try something like this instead. Oh, there is a warning. Okay. Initialization discard cons qualifier from pointer target type. Okay. So maybe we can do this. The casting. Okay. Let's try this out. Printf Q. Q42. Okay. One of the use case cons in okay. We can assign non-cons memory attached to cons pointer, but for safety reason this make me curious. I mean, we only got a warning, right? But will it still okay? It will still green. When we assign rate of cons to non-cons, we will get a link from the compiler. Okay. One of the use case of pointer The const element is a function parameter. Okay. A function that takes a pointer to non-const. A pointer to non-const as parameter can modify the value passed as argument. That takes a pointer to non-const. Non-const can, as parameter, can modify the value passed as argument. Okay. While a function that takes, okay, this might be, what is it called? Kind of confusing, I guess. But when we declare a function, this one, we call it parameter. But when we, what is it called? When we call the function, like where is it? This one, we usually call this argument, as far as I know. So yeah, parameter and argument can be confusing sometimes. Well, a function that takes a pointer to const as parameter cannot. Okay. Const start, const in. Cannot. Print all uses pointers that point to constant element. To constant pointer. Send to memory. Yeah. Const element. These pointers point to constant content. They cannot modify, but they are not constant themselves. They are not constant themselves, okay? The pointers can still be incremented or assigned different address, although they cannot modify the content they point to. The pointer can still be incremented or assigned different address. And we increment, oh, this one. Increment pointer. Okay. But they cannot modify the content they point to. Okay, so the constant is the value that point to, not the, what is it called? The pointer value, I guess. Let's try this out. For it, print all. For it, const in start. equals in current equals start. Current okay. Equals in stop. Well, current current not or less than or equal to stop, right? Printf current. Current and then plus current. I mean, because we didn't assign this one, it didn't really matter whether we use plus current or current plus. Okay. Increment value pointed to. But yeah. Interesting. Not equal stop. How do we stop this if we cannot increment the value of current? Let's find out. What is it? 1 and then 2. Oh, right pointer. And Y and then oh, using an array. Okay, interesting. Then let's use an array too. P and then P plus 2, I guess. Eleven, 20, 30. Bocah. Oh, right. Okay. It's because we are using an array, right? Okay, I mean, if you're not using an array, this may cause segfault. Oh, not really segfault. More like the while loop did not end, I guess. let's try that out. Let's say we have x 42 x y. Okay, I think I'm gonna reproduce buffer overflow. Oh no, interesting. What is current plus plus? Hello, welcome, Kenya. Nothing. But nothing stick. Okay. I'm currently learning C, so I'm not really sure if this help. Maybe you can take a look at this tutorial too. I'm currently learning about pointer. How long have I been studying C? Maybe around a month or two, something around that time, I guess. Yeah, probably 2 months at this point. I'm not really sure how long I've been going. Current equals stop. Interesting. This make me curious. Let's print out start, right? The pointer. And then start. What is it called? Stop. Is the memory address side by side? I cannot tell. You know what? Let's try using the integer equivalent. Oh, okay. $49,048, right? And then this 152, because the size of integer in my system is 4 byte. Okay, we are lucky enough to satisfy this, what is it called, condition, I guess. I mean, in some cases there is no guarantee that the memory address is side by side. Nice, okay. So yeah, this can cause a problem if we are trying to access the what is it called? To access the unsigned memory. Is that what it is called? Okay. So I mean, if I'm like, what is it called? X x, right? If I'm doing this, y, then x. No. Okay. We are not even entering the while loop, right? Because the start is more than, what is it called? The stop memory address. And it using the not equal sign can cause some problem. That's in this case because the start is more than the stop, so we never end the loop. See, segfault. That's why we need to be careful. Okay. Let's add information. This will print the value of x. No, not in this one, I guess. Or maybe, this can cause this can cause some problem if the memory address of x and y is not contiguous. Okay, this one. Side by side. Right, that's the word, right? Let me check first. Okay, contiguous. If not, because we might to access some memory that does not exist, or does not exist, or not having the access to. Okay, and let's try this one, right? We are trying to increment the value instead of the pointer. Current plus. Okay. Will GCC throw an error? Yes. GCC throwing an error. Okay. Increment of read-only location. Alright. at least the compiler warning us about the cons. Okay. But incrementing the cons value. Alright. Not that when I use pointer. This pointer. Print cons. Okay. This pointer points to constant content they cannot modify, but they are not constant themselves. The pointer can still be incremented or assigned different address, although they cannot modify the content it points to. We can increment the pointer itself, but we cannot increment the value. Okay, the value that the pointer points to. So the constant value, in this case the constant applied to the in this case what you doing? Okay, I'm currently trying to learn C by reading this book, and wait a minute, and currently we are on the chapter 11, right? But before I continue reading this chapter, I found out about this function pointer. So currently I'm trying to learn more about the pointers before diving into the function pointer. And we are learning from this at the moment. This tutorial about the pointer. Okay, oh right. What we are creating is something like this. If you know about Python, right? We can do something like this, and this is what we have created so far. A Lisp interpreter for learning C. How many years have you been learning C++? I haven't learned C++. I'm learning C. So, and I guess it's only been 2 months. So yeah, it's not a year yet. Yeah, just C. Even though the tutorial we are looking at is C++. Yeah, I've been going for this about 2 months at the moment. So not even a year yet. That's why my explanation might be incorrect, because I don't have any experience yet, and well, I'm currently learning. about C, right? So if anyone knows what is incorrect about my explanation, please let me know. Because again, I'm still have no experience about C and well, C++ too.
Online. Mau makan apa?
Ya, tadi apa?
Mie bakar atau apa? Oke.
Apa?
Paru.
Ya, pari lah apa?
Paru. Sore. Atau gurame bakar nanti sore.
Ya wes. Ya.
Minggu ini keluar nggak gurame bakar?
Maksudnya?
Sudah pernah makan gurame bakar minggu ini?
Belum,
Bang. Iya lah.
ya nggak apa.
Mata nyuci baju.
Iya.
Besok air.
Oke. Paru nih.
Paru.
Oke.
Iya.
Yeah. Okay, so is it like your first time learning a coding language? Or maybe I have a prior knowledge of another language. Oh, this is not the first time I'm learning about programming language. Previously, I have some experience with JavaScript and then TypeScript and also Golang. I guess I've made this simple project about Golang. So yeah, this is not the first time I'm learning programming language. I have some experience with another programming language like Golang. In case if you want to see, I'm also building this live stream. You can find it on my YouTube channel, I guess. In case if you are curious about the process of building this. So yeah, I have prior knowledge on other programming language. And now I am trying a new programming language, like C. Okay. I guess let's take a break. Okay. Oh, there's a lot. Oh yeah, this is also another reference for the pointer. I mean, in Golang we also have pointer, right? So I kind of learned about pointer a little bit from Golang, so it's not really new, but again, I find something new when reading this tutorial, you know. For example, this one. Let me show you. Where is it? This one. Like the square bracket, right? Usually we think of square bracket to access the index of an array. But it turns out that it is a part of the referencing operator, you know. Dereferencing the pointer with offset provide. So what this means is that we can dereference a pointer like this one, the E2 pointer, with this symbol, with the square bracket like this. I mean, previously I didn't know about that, so that's quite shocking, you know. And if we, I guess, compile this again, what is it called? Let me run this. This one is it's actually the same, using the square bracket and the asterisk symbol to dereference a pointer. So that's quite interesting. I didn't know about that previously. You're welcome. I mean, I'm doing this live stream to learn together, so no problem. And also by explaining this, I kind of understand more, I guess, like what I truly understand and what I'm not sure about, right? So it's also good for me to explain things. Okay, in this case, constant is for the okay. Well, take your time, I guess. I mean, you're using Feynman. Wait, what? You're using Feynman? I didn't get it, I guess. Oh, okay. Well, you're welcome. Let's learn together. In this case, constant is for the value rather than the pointer itself. Okay, maybe something like this. Constant is for the value rather than the pointer itself. Is this the right way to explain this? The pointer value, but I cannot increment the value that the pointer points to. Okay, the pointer points to. In this case, constant. This case, constant is for the value that pointer points to rather than the pointer value itself. Okay, I guess. Oh, right. For the people who just joined, the pointer basically. Okay. Basically, Feynman technique is a method of learning where you learn by breaking complex topics to simple ones while teaching it to others. Oh, okay. Yeah, I didn't know that the technique have a name, I guess. Okay. Complex topics to simple ones. Alright, I learned something new again. Thank you. Feynman technique. Oh, I think I've heard about the Feynman. Like, is he some, what is it called, scientist? Yeah, even though you don't understand the subject that much, you get more insight when explaining to others. That's right. That's why I'm also trying to explain things to anyone. He's that scientist. Okay. That's it. I mean, Richard Feynman. Okay. Alright. That's why I feel like Feynman sounds familiar. So, is that the same Feynman? That it turns out it is the same Feynman. Okay. Okay. What exactly are pointers? All right. Let me. Where is it? Okay. By usually, right? Usually we assign a value, right? For example, let's say, what is it? U equal 69, right? We assign, let's say, number value, or maybe we can also assign a string, what is it? A text, to put it that way. And well, this is the usual way, but pointer means that we can store a memory address. So every time we having this value, this mean we are initialize a variable. So we create a new variable called u with 69 as the value. And what this means is that we are trying to save the value of 69 in the memory with the label u. So, and what memory is, and what I mean by memory is something like this. This is the memory address. So, okay, let me, I guess, put my blog post. Okay, I've made a simple analogy about pointer. We can think of it like a warehouse. That's suspicious, Susan. That's a I mean, we can assign any value, you know. If you don't like 69, let me change that to 42, right? Not 69, now we have 42 as a value. Anyway, we can think of memory like a warehouse. Okay. We have this warehouse, and we have a warehouse key with the keychain in the key, right? With the keychain in the key. And then the keychain is the memory address, the address of the warehouse. So the pointer is like the key to the warehouse. I think we can think of it like that. So the pointer is like a warehouse key, and then the memory address is like the keychain that attaches to the warehouse key. And then when we are trying to access the value in the warehouse, we are opening the warehouse using the warehouse key, using the pointer. So think of it like a warehouse, and then we have warehouse key, which is the pointer, and then the keychain attached to the warehouse key, right? Which the keychain has information about the warehouse. So then we know, this key points to, let's say, warehouse 69, right? Then we take a look. Where is warehouse 69? Oh, we found the warehouse 69. And then we try to open this warehouse using the key. I think that's the simple analogy of pointer. Okay. Let me post the blog post there. So we can think of pointer like, or memory, I guess. We can think of memory like a warehouse, which have warehouse key and then the keychain. Okay. Nice. Okay. Let's continue. Wait, not this one. The pointer can still be increment or assign different addresses. Although they cannot modify the content they points to. And this is where a second dimension to consciousness. Is that the word? Okay. And this is where a second dimension to consciousness is added to pointers. Pointers can also be themselves cons, right? And this is specified by appending cons to the pointer type. Okay, after the asterisk, right? So we can, what is it called? We can make the pointer constant, which means we cannot change the memory address value in the pointer, like in the, what is it called? In this analogy, we cannot change the, what is it? The keychain, right? That's what it means by the const to the pointer. We cannot change the keychain, and yeah, we are stuck with it. Now, if we are not using const, which is not constant, we can change the, what is it? We can change the keychain too. In my analogy of pointer. Okay. Alright, let's try this out. I guess we can try this in here. Right. Cons in asterisk cons current. That is very confusing. Okay, alright. I expect an error here. Alright. See, we got an error. Increment of read-only variable. So we declare that current pointer cannot change the keychain or the address that we are saving in the pointer. So it's fixed. Yes, it is fixed. Okay. But with this one, we can change the value of the, what is it called? The value of the pointer. Let me show this, I guess. Okay. Okay. Alright. No, not that one. Okay. And well, as we can see, oh, the current, okay. There is a difference, right? Current in here with the current in the last one. So we are basically changing the keychain with this operation. Current plus plus. Like we have the same key, but we replacing the keychain attached to the key. So that is also possible. Alright. Wait. Current, okay. Yep. Oh, let me explain this. This one is different from this one, and then it is also different from this one. And why is it printing double? That is interesting. Oh, right. Okay. We are printing double because of this, I guess, but that should not be the case though. Interesting. Yep. I'm still not sure. Why is it printing double in here? Or maybe something like this. So we are only printing. Okay. Yeah, I guess this is less confusing. We have this one, the current, what is it called? Current memory address or the current keychain, and we also have a new keychain for the same key, the current key. Okay. I may have to take my leave for today. Alright, see you next time. Okay. Good luck with learning programming too. Okay. The syntax with cons and pointers is definitely tricky. Yeah, that's right. The syntax with cons and pointer is definitely tricky. And recognizing the case that best with its use tends to require some experience. That is okay. So in any case, it is important to get consonants. This is new. Consonants with pointers and reference, I guess. Right, sooner with pointers, right? Sooner rather than later, okay. But you should not worry too much about grasping everything if this is the first time you are exposed to the mix of cons and pointer, okay? More use cases will show up in coming chapters, alright? To add a little bit more confusion. Okay. So we are adding more confusion now. Interesting. To the syntax of cons with pointer, the cons qualifier can either presets or follow the pointer type with the exact same meaning. Non-cons pointer to cons in. Non-cons pointer to cons in. To cons in, okay. So non-cons pointer to cons in as with the spaces surrounding the asterisk. The order of cons in this case is simply a matter of style. Okay, so I think both of these is the same expression, right? Okay, interesting. This chapter use a prefix cons. As for historical reasons, they seem to be more extant, but both are exactly equivalent. Oh. This chapter uses a prefix cons. As for historical reason, this seems to be more extant. Okay. The merits of each style are still intensely debated on the internet. Okay. Adding the fuel to the fire. We are adding more confusion. Okay, pointers and string literals. Oh. As pointed earlier, string literals are arrays containing null-terminated character sequence. In earlier section, string literals have been used to be directly inserted into, this is the C++ syntax, I guess. In C, we are using printf instead of code. I'm assuming. I never tried C++ before, so this might equivalent to printf. Okay, and then to initialize string and to initialize arrays of character. Okay. String literal basically just an array of character with null terminated character at the end. And as far as I understand, string literal is safe in a read-only memory. Like for example, I'm not sure if I already saw this. I guess this one, right? So if we have this anu variable, and then we try to use anu again, we will get the same pointer. Let me show you this. String literal background, okay. This one, string str1 and then str3. Okay, str1 and then str3, right? Okay. Oh, it is interesting. So, and as far as I know, this will still exist until we, what is it called? Until we exit the program, I guess. So let's say we change the string literal in another function, str2, for example, I2, right? And we are using that again in, where is it? In this one, it str2, right, we are actually using the same as the str2, the same memory address as str2. It is quite interesting. Okay. And because we are in the read-only memory, right, we cannot change the character itself. So let's see, string literal, okay, and we are trying to change str0, for example, rather than a, wait, rather than a in enu, we are trying to use I, for example. We cannot do this. Playground string literal. Wait, oh, right, I forgot to put the name, the file name. Okay, this one. We got an error, assignment of read-only location. So we can think of it like a constant character, you know. So we cannot change the character itself. We only able to replace the pointer, right? Now this is working fine. So we are replacing, in my analogy, we are replacing the keychain, but we are still using the same key for the pointer. Okay, that's a little bit about string literal, and then we'll continue to initialize string and to initialize array of character. But they can also be accessed directly. String literals are arrays of proper array. Wait. Arrays of proper array type to contain all its characters plus the terminating null character. Okay, with each of the elements being of type const character, right? Each of element being constant character. As literal, they can never be modified. Yeah. Basically, string literal is an array of constant character. I guess that's the easy way to understand this. Because it is a constant character, I cannot really change its character in the string literal. But we can change the memory address that what is it called? That points to another const character, you know, another constant character, like this one. We are basically changing the keychain in my warehouse analogy and then change it back to the str1 keychain or memory address. Okay. This declare an array with the literal representation for hello, an array for the literal representation for hello, and then a pointer to its first element is assigned to foo, right? Because this is also an array of constant character, we basically assign the first constant character in this array to full. Okay, first element is assigned to full. Okay. If we imagine that hello is stored at the memory location that starts at address 1702, we can represent the previous declaration as this one. Don't forget the null terminated character. Because if we didn't have this null terminated, we will keep going until we found the null terminated. I've already tried that in the, what is it called? String line, I guess. No, not that one. Is it in the overflow? Cygnus, no. Is it in this one? Not that one. I kind of forgot. Where do I place that? Not pointer. Okay, no, not that one. String playground, I guess. Right, okay. String playground. Okay. This one, A1, have a null terminated character, right? So we stop at AP when printing the string literal. But this A2 does not have null terminated character, and well, we are using the array representation instead of the pointer representation. So what this do is just keep going until we found null terminated character. Oh yeah, there is a difference between providing the size of the character array and not. If we are not providing the size of the character array, the compiler will automatically insert the, what is it called? The null terminator character, I guess, this one, \0, at the end of the string literal. As far as I understand, I mean, I'm not really sure yet, I guess. Okay, for example, this one, why we are on this string rather than the B1 string, you know? I'm still not sure why. But yeah, it exceeds the expectation of the string literal. Okay, so because it is an array, it needs to be contiguous side by side, right? If this is 1702, E have 1701, L have 1703, sorry, A have 1703, this L have 1704, 1705, 1706, and then the last one is 1707. So basically that, note that here foo is a pointer and contains the value 1702, and note it's nor hello. Okay. So foo contains the memory address instead of the character itself or the value itself, right? And then the compiler translate that to what is it called? Translate that as a string literal and get the rest of the string literal until we found the character null terminator. This \0. Okay, artdoc 70 in the test output of this. Okay. The pointer foo points to a sequence of character, and because pointer and arrays behave essentially in the same way in expression, foo can be used to access the character in the same way arrays of null-terminated character sequence are. Right. Both expression have value of 0, the fifth element of the array. Let's try that out in here. Let's say, wait a minute. Let's say we have this constant xy set I guess. Holy see. Okay, and then we are trying to print the end by 1, offset 1, I guess, and character, and then inu 1. And then I can do this too. Plus 1, or maybe 3, I guess. Okay, plus 2. Oh, right, the offset. Okay. Oh, conflicting time. Okay, we already holy. Let's change inu to holy. Wait, pointer and array. Okay. Bocor. Running this again. Yes, it is the same. Because pointer and array we have a session. No, how do I pronounce that? Essentially the same. This okay. The same way in expression. We can access in the same way character in string literals in the same way as arrays, as array of characters. With no terminated character at the end. But expression have value 0, the fifth element of array. Pointers to pointers, okay. Allows the use of pointers that point to pointers that these in turns point to data or even to other pointers, okay. The syntax simply requires an asterisk, right, for each level of indirection in the declaration of the pointer. Okay, the two-star programmer. Some people call it how many stars do we use? This assuming the random chosen memory for each variable of okay. Okay, so basically we have set character, right? And set character is live in the memory address 7 to 30, right? And then we assign this memory address 7 to 30 to the B pointer, right? And B pointer itself have a memory address of 89.2. This is what the diagram looks like. So 89.2 is the memory address of B, and the 7 to 30 is the memory address of A, and inside of the address A, we have character set. Okay. with the value of its variable represent inside its corresponding cell, okay, and their respective address in memory represented by the value under them. If I remember correctly, we can also access the array of pointer using pointer of pointer too. Okay. With the value of its variable represent its corresponding cell and the respective address in memory represent by the value under them. The new thing in this example is variable c, which is a pointer to a pointer and can be used in 3 different levels of indirection. Each of them would correspond to a different value. C is of type char, pointer pointer, and a value of 1892. This memory address is the value of C, which, as far as the assumption goes, C have a memory address of 10,502. Okay, and then pointer C is of type pointer char and a value of 7230. Okay, then pointer C is of type char with a value of Z character. Okay, void pointers. The void The void type of pointer is a special type of pointer in C or C++. Void represent the absence of type. Therefore, void pointers are pointers that point to the value that has no type. Void pointers are pointers that point to a value that has no type. Okay, and thus also an undermine length and undermine the referencing properties. Undetermined length and undetermined differencing properties. Okay. Interesting. This gives void pointers a great flexibility. I'm kind of curious though. Like, for example, let's say we have void pointer what is it called? We cannot use void, right? Void C. Holy void. And then what happened? Like the size, the size of holy void. This is T, for example. Alright, size of because it is a pointer, okay. Let's do this instead. And then put that char new line in here. Okay. 1. Oh, interesting. I mean, if I change this to in, right? We will have 4. Oh, okay, interesting. How about the plus plus though? Like let's see. I mean, holy, for example. Can we do that? No. Well, there is a warning, I guess. One. Rather than holy, let's use P, right? Speed. Oh. Okay. I mean, like, stem size of, what is it called? Only void plus plus. Let's put it this way. Interesting. Okay. Now let's try using P, right? Or maybe num, integer of an array of integer. Okay. out. Oh, when using plus plus, we are increasing by 1. Even though let's check if we can do this. If we can check. Oh, you're starting C++. Nice. I mean, I haven't tried C++ yet, so I'm not sure what is the difference between C++ and what is it called? And C. So yeah, maybe we can learn together too. Okay. Holy foil. Easy with class. Okay. See with class. Alright. I mean, some people say that C++ can be way different than C. So I'm not sure if it is only C with class or something like that. Okay. What do I want to do here? Like dereferencing, right? Okay. Maybe something like this. I'm not sure if it is possible though. Okay. Dereferencing void pointer. Okay. Dereferencing void pointer. Alright. Interesting. Invalid use of void expression. Let's check this out. Okay, looks like we cannot dereferencing void pointer. Interesting. Or maybe we need to cast this into something like this. No. Okay. What Linux distro am I using? I'm currently using Arch Linux. archlinux.org. This one. I'm currently using Arch Linux. I don't really recommend this for new Linux user, but the reason I choose Arch Linux is because it is simple. See, simple does not always mean easy. So there's the catch. It is simple, and it is a rolling release distro. What that means basically, instead of updating the OS, I'm only updating the package like the Linux kernel, VirtualBox package, and other stuff, So basically I use this because it is simple and I want to learn about operating system, right? So as Linux helped me understanding a little bit about operating system. I'm one of those guys who say I use arts, by the way. I'm trying not to, but yeah, I use arts, by the way. I'm one of those guys, maybe, but I'm trying to not saying this phrase, But yeah, maybe I'm one of those guy. Who knows? This keyword. Okay, this is actually interesting. We cannot dereference void pointer. Wait, let me read this first. This gives void pointer a great flexibility by being able to point to any data type from integer value or a float to a string of character. In exchange, they have great limitation. Okay. The data pointed to by them cannot be directly dereferenced. Okay. Alright. It is logical since we have no type to dereference to. Okay. That's why we got this error, right? Or maybe in this case warning. Invalid use of expression. This type of error. Okay. And then for that reason, any address in a void pointer needs to be transformed into some other pointer type that points to a concrete data type before being dereferenced. One of its possible use may be to pass generic parameters to a function. Okay. Void increase, void pointer data. Okay. Alright. In p size. Okay. If p size equals size of char to this pointer to char p char, and then okay, what is it called? We cache the data with use pointer to void and then assign that to pchar variable, and then we can dereference and increment the value. Okay, interesting. Rather than using if, maybe we can use switch case, I guess. Okay, let's try that out. Before that, let's take a break. Be right back. I'm back. There is 5 minutes left. Okay. Okay, point increase. Oh, yeah. For some reason, my shoulder kind of tired, I guess. Okay, void increase. Excuse me. Can we use size? I think we can, okay. Oh, invalid pointer and null pointer. Okay. Size. Okay, this is kind of interesting. So basically we need another variable to be able to increment, to be able to dereference the data inside the void pointer. Okay. Interesting. Only void. Let's start early. Data in. I don't think this will cause a problem, right? Okay, yep. So basically we can provide different, different variable name in the function definition. Is that the name? And what is it called? The different parameter name in the function prototype and in the function definition, like this one, I guess. Okay. Well, let's check this out. Printf unknown. Return. No. not return. Why did I? Oh, okay, yep. Increase only for it. Only for it. Oh, okay. I guess we will use X and Y. X and then this one, size of X. Yep, because it is cons. Maybe I should create a new one, or just using P, right? The first, the index 0 element, and then using this one. Okay. Okay. Size. Let's try using switch case instead. I kind of forgot the syntax. Switch size. I don't think we can use this one. What is it called? The switch case. Let's find out size. Size. No, okay. P char, pointer char. this one picture. Is this valid? It compiled at least. Interesting. P increase. Okay. So it is possible to do this. Interesting. Wait. Right. Right, oh, this one, okay. I suggest this in char in. Okay. What are we increasing in here? In A. Interesting. Let's try using the character. What is it? Let's use 3, right? Increase str, right? We are providing the memory address of the first character, which is A, and then size of str. Let's see. How it goes. A. Maybe we should do this. Still A. Okay. I can forget. Oh. It looks like we cannot use switch case. Alright. Okay then. P size equal size of jar. Okay. Right. P size equal size of in no break in str increase wait. Why this one? Okay. Oh. Okay. Just got jar. Alright. This is interesting though. Like we are not really increasing. Oh, okay. From A become B. Alright. Okay. So we are increasing the hex number, I guess. ASCII table in here. I think this one. Oh, this is the you're basically having this, right? No, not the uppercase one, but the lowercase. We have this hex number, or maybe this decimal, and then we increment this, so it become P, the 98. I mean, I guess I can print that out. Oh, what is it called? Picture, the current one, right? KP, and then picture, something like this. Oh, wait, C programming language format specifier hex number. I think this one. Oh, using X. Let's try. I don't really remember. No. And it, okay. Let's check. Oh, sorry. This should be right. We should dereference that first. Okay, 60 first. This one, right? The hex number. Or maybe we should just use the decimal. Decimal like this, and then print out what happened after that. This is this one, the lowercase a character in ASCII and then this is after we increment the value, it becomes p. Character in ASCII. I mean, previously we also know about UTF-16, but yeah, there's also the case. Okay. Size of is an operator integrated in C++ or C language that returns the size in bytes of its argument. For non-dynamic data types, this value is a constant. Non-dynamic data type, size char is 1 because char is always a size of 1 byte in UTF-8 system, I guess. With pointers and null. Valid pointer and null pointers. In principle, pointers are meant to point to valid address, such as the address of a variable or the address of an element in an array. To point to valid address, the address of variable or address of element in an array, but pointers can actually point to any address, including address that do not refer to any valid element. Okay. Typical example of this are uninitialized pointer, right? I think, and pointer to non-existent element of an array. Non-existent. Okay. In my example, in my analogy, the warehouse analogy here, let's review this a little bit. The warehouse key is the pointer, the keychain is the address that attached to the warehouse key, and then the warehouse itself is the memory, right? So an initialized pointer means that we have a key, but we don't have the keychain, so we are not sure which this key points to, right? Which this key open to in this analogy. So that will cause the problem. An initialized pointer, elements out of bounds, right? My array plus 20. Okay, because this is the reference, can also mean the reference, right? So I think then str, let's use, what is it called? A char. A char, alright. picture increase. Let's see if it is compiled. Yeah. Picture and a char. A char become picture. Okay. I think I want to add what is it called in this one, right? Okay, I think we can also do something like this. Plus, oh sorry, this one index 0, the offset is 0. Okay, so we cannot really do that in this one. Plus 1, the offset, right? And then a plus 1. Where is it? This one. Okay. Alright, we already done that with the offset 4. Okay, I think we don't really need that. Neither P nor Q point to addresses none to content value, but none of the post statement causes an error. Okay, because we haven't used this one, and we haven't dereference, I guess. So we have the key in my warehouse analogy previously. We have the key, but we are not trying to open the warehouse yet. Allow to take any address value, no matter whether there actually is something at that address or not. So let's say we have P and then num plus 69, right? Okay, it works fine because we are not trying to open the warehouse with the key with this pointer. Okay, so there's that. No matter whether there actually is something at that address or not, what can cause an error is to dereference such a pointer, actually accessing the value they point to. Accessing such a pointer causes undefined behavior, ranging from an error during runtime to accessing some random value. Okay, I guess this is what it means that C and maybe also C++2 did not have garbage collector because what is it called? When we free the memory, right? We are not cleaning up what's inside the memory. So we might get some random value there. Okay, But sometimes a pointer really needs to explicitly point to nowhere, and not just an invalid address. For such cases, there exists a special value that any pointer type can take, the null pointer value. For such cases, there exists a special value that any pointer type can take, the null pointer value. This two ways, either with integer value or zero. Integer value of 0. In C++, there is this null ptr, but in C, I guess we can use null macro, I guess, or just using 0. Usually in ASCII, 0 means null or non-terminated, I guess. Here both P and are null pointers, meaning that they explicitly point to nowhere, right? And they would actually compare equal. Null pointers compare equal to other null pointers. Oh, okay. It is also quite usual to see to find console null be used in other code to refer to the null pointer value. Yep. We are using this in the, where is it called? In this one. We initialize the value pointer with null or 0 value. So this means that the value is null, and also I think not this one, I think this one. Okay, this is read the number, right? For the tuple, okay. And pointer row, basically until we found the null terminated value, as far as I remember that. Okay, and then wait, where is it? Oh, this one. We also assign cell, which if we take a look at this struct, cell is a pointer of pointer, and we initialize cell with null character. Okay, we are also using this. Null is defined in several headers of the standard library and is defined as an alias of some null pointer constant value, such as 0 or null ptr in C++. Do not confuse null pointer with void pointer. Okay. Null pointer is a value that any pointer can take to represent that it is pointing to nowhere. Right? It is pointing to nowhere. Well, a void pointer is the type of pointer that can point to anywhere without a specific type. So there's no guarantee that when we declare the pointer like this, we have the valid memory address. What is it called? The easiest solution is to use null to initialize a pointer. Okay, well, avoid point to somewhere without a specific type. One refers to the value stored in the pointer and the other to the type of the data it points to. One refers to the value stored in the pointer to the data it points to. Alright, welcome. Let's learn together. One refers to the value stored in the pointer and the others to the type of data it points to. The type of data is point to is that mean the void pointer here? Okay. Alright then. Pointers to function. Okay, we finally getting to the pointers to function. C++ or C allow operation with pointers to function. The typical use of this is for passing a function as an argument to another function. This is for passing a function as an argument to another function. Okay. Pointer to function are declared with the same syntax as a regular function declaration, except that the name of the function is enclosed between parentheses and an asterisk is inserted before the name. Okay. This is the function pointer. Okay. Addition, right? And then subtraction. Okay. Operation. Oh. That is something. Okay, and then we use this function pointer. Oh. Okay, interesting. Do we need to use asterisk for the function pointer? Return G. Let's try that out in the, where is it? In the function pointer background here. Oh, okay. Interesting. X and Y. And then we're returning G. And G is integer. Oh, interesting. I mean, do we need to use use asterisk here. Maybe we can try this out in here. Let's compile that. What is it? Function pointer. Okay. Function pointer. Okay. Oh, all right. Okay. We can, I guess. What about this one? Can we? Nope. Invalid argument. Okay. Still the same. Okay. Do I already? Yep. Let me commit this first. Add another format to call function pointer. We can pointer with the syntax like when we declare the function. For example, what is it? Something like this, right? Yep. Okay. Add assume is a function are 1 and 1 and 2. I mean, I think this can be easier to know that this is a function pointer. Okay. Okay, we are assigning the memory address of subtraction into the function pointer minus, right? And then we are using this as the argument for this parameter func to call in. Okay. In the example above, minus is a pointer to a function that has two parameters of type in. It is directly initialized to point to the function subtraction. Alright. Let me also add in this one the pointer and array example. Pointer can we like do this? Void pointer and then in, right? Okay, it works. And then it compile, not it works. Function pointer. Or maybe we should put this in this line. Equal increase, right? And then we can use this in this one. Function pointer execution or let's just call it function pointer, I guess. And then we run this. Function pointer p and then size of p. Okay. Invalid use of void expression. Interesting. It should not affect anything, right? Okay, not this one. Multiple indirection. Check this one. Oh, okay. Alright, I guess we can use something like this. Invalid use of pfang. Invalid use of void expression. Interesting. Why is it invalid though? Wait. Maybe we can use something like this. Increase. Oh, okay. So the problem is on the printf. Alright. But yeah, well, I mean, can I like do this? Size of yep. We can do this. Like why? Okay. Called object is not a function or a function pointer. Wait. Does that mean we can do this? No, we cannot do that. I guess, okay. I'm still not sure what's going on in the array. Okay. Pfang increase like what? Why we have this much increase? It's 12, right? Oh, okay, right, sorry. Yep, we haven't the reference. So previously in this one, we are printing out the pointer as integer, or the memory address as integer, instead of the value in those memory. Okay. Interesting. Okay, let's take a peek first. Okay. Wait, oh, did I add already closed that. Looks like I'm already closing that. Okay. After this article or this tutorial, I'm planning to take a look at this article. Let me put this in the chat. In case anyone wants to see this too. And then yeah. Do I might also read this. This is related to UTF-8 and UTF-16, I guess. There's also UTF-32. So yeah, but this will be the last. Okay. Let me go to the bedroom first, be right back. Okay, I'm back. Okay, let's take a look. Sound paragraph. Okay. Starting off, say you declare okay. This variable occupies some memory on current mainstream Intel processors. It occupies 4 bytes of memory because an int is 4 bytes wide. Now let me put here in the reference to now let's declare another variable, okay, full ptr, right? Declare as a pointer to int with initialize, okay. Address of int operator. Every variable as a box. Foo is a box that is size of int bytes in size. The location of this box is its address. When you access the address, you actually access the content of the box it points to. Right. This is another analogy, I guess, other than the warehouse analogy. Okay. Of all variable regardless of type. In fact, grammatically speaking, wait. Let me add an explanation in this one. We can pass in any data because any pointer type, because we in data parameter, because we are using using void pointer as the data type, but the problem is that we cannot directly dereference void pointer. We need to wait. Okay, let me close this. Alright, for those who just joined, this is what I mean by the warehouse analogy. It's basically think of pointer like the warehouse key, and the warehouse itself is the data storage or memory, and then the address, the memory address, is the keychain. So basically we have key, the pointer, and then the keychain attached to the key, and then when we want to access the value inside the warehouse, we use the key to open the warehouse. This is an analogy for dereferencing a pointer. Okay. And then what is this? Okay, let's close that. It's kind of the same with this, but instead of warehouse, we use a box as the analogy in here. Okay, the problem is that we cannot directly dereference pointer. We need to, what is it called? We need to, what we need to do? We need to assign, I guess. We need to transform. We need to transform the pointer, the void pointer, aka void pointer, the reference into the, I think, casting, right? Oh, let's just use transform. Transform the void pointer into the existing type pointer, like in or char. Okay, think of every variable as a box. For is a box that is size of int. Okay, bytes in size. The location of this box is its address. When you access the address, you actually access the content of the box it points to. Okay. This is true of all variables, regardless of the type. In fact, grammatically speaking, there is no such thing as a pointer variable. Okay, all variables are the same. There are, however, variables with different types. Whose type is in, ptr type is in asterisk. Pointer variable really means variable of a pointer type. Variable of a pointer type. Okay. The point of that is that the pointer is not the variable. The pointer is not the variable. Okay. The pointer to foo is the contents of foo ptr. The pointer to foo, I usually call this memory address, I guess. Memory address to foo is the content of foo ptr. The pointer is not the file. Okay. You could put a different pointer in the foo ptr box and the box would still be foo ptr, but it would no longer point to foo. Okay. Pointer has a type too, by the way. Its type is in, thus it is an in pointer to in. Okay. An in asterisk type is in asterisk. It points to a pointer to in. The use of pointer to pointer is called multiple indirection. Okay. The two-star programmer, right? Okay, multiple indirection, more on that in a bit. Declaration syntax. In a single declaration is, it is wrong because the asterisk is on the variable itself. So what this means is that we have a pointer a that points to, we have a variable a that points to in value, right? And then we have variable ptr b with integer value. If the type of a variable containing a pointer to in is in, and a single declaration can declare multiple variables of the same type by simply providing a comma-separated list. Okay. Multiple in pointer variable by simply giving the in the type followed by comma-separated list to use. What is the type? Yeah, it is not pointer in, not the asterisk in, or what is it? The terminology, address of, dereferencing. No, I don't think. Nah, let's just call it pointer in. Okay. Is wrong. The type of ptrp is in, right? So the star actually what is it called, attach the star or the asterisk attached to the variable, not the, what is it called, the type. So again, this means that the ptr underscore a points to in value, right? Pointer to in value, and this one ptr underscore p is having the integer value, not pointer to integer value. It is not a pointer. Okay. This declaration syntax ignores the pointer asterisk when carrying tab over to multiple declaration. If you split the declaration off to multiple declaration, you get this, right? So this one can also be written like this. It's actually like this. The, what is it called? The parsing mechanism. Okay. Think of it as assigning each variable a base type in plus a level of indirection indicated by the number of asterisks. The RP is 0. Okay, this is interesting. The number plus a level of indirection. That's one way to look at it, I guess. A single, in a clear way, this is the immediate improvement. Okay, see, the asterisk attached on the variable name, not the type. Okay, a subtle implication of association. It's even clearer to put the non-variable first, right? The absolute clearest is to keep every declaration on its own line. Okay, but that can take up a lot of vertical space. Just use our own judgment, right? Finally, I should point out that you can do this just fine. There's nothing wrong with it. Okay. Incidentally, she allows 0 or more level of parentheses around the variable name and asterisk. Okay. 0 or more level of parentheses. Oh. I mean, okay. This is too much. But it is valid though, right? I mean, I think we can try that out. Where is it? This one, right? Wait, can we like... Oh, nope. Okay, let's compile. Yep, it is working fine. Increase 12. Where is it? The increase. I think it's put. Oh no. Yeah, because the increase using the void. Okay. So this one is one section, I guess. increase. Okay. This is not useful for anything except to declare function pointer. Okay. The right left rule for writing C declaration. I think this is another way to read C declaration, but I'm usually using the, what is it called? Clockwise rule. C programming clockwise rule. I think it is in the live stream description, but yeah, we have a lot of references. It's kind of hard to find out. Is it this one? I think it is this one. I usually using this kind of, what is it called? Kind of method to learn to decipher the, what is it? To read the C declaration. Clockwise spiral rule. So we are like spiraling like this to read what's going on. This one. What is str? And then we are get this one, right? The array of 10, and then we are seeing this asterisk. Oh, it means it is pointer, and skipping this one, and then we got to the char type. Okay, but this make also work, I guess. P identifier, right, left, right. Oh, check the right first, and then is array of, and then check the left. Okay, interesting. Fun, right, and then right first, move right. Function returning, because of the right parenthesis. Oh, because of this one, and then turning into the right. Sorry, to the left. Okay. Function returning pointer to, and then we cannot move to the left anymore because of the parenthesis. This one, move to the right. To function returning again. We are out of symbol, so go to the left. Oh. Pointer to in, okay. I think this might be easier, I guess. Fun one is a pointer. Okay, so we are already, what is it called? Wait, is there any? Okay, step 1, find the identifier. Identifier is look at the symbol on the right of the identifier. If say find the parenthesis, that this is the class of a function, so you would then have the identifier is function returning square bracket, there identifier is array of until you run out of symbol or hit right parenthesis. It's only the right parenthesis. That's the beginning of, okay. There is stuff in between the parentheses. Move more on that below, okay? So if we found the left parenthesis, it means the beginning of the parenthesis symbol. At the symbol to the left of the identifier, if it is not one of our symbol above, just say it, okay? Translate it into English using the table above. Okay, this is the table. Keep going until you run out of symbol or hit left parenthesis. And format your declaration. Okay, let's check this one. Fun one is we hit the right parenthesis. This is a pointer to right. Pointer to, okay. Fun one is pointer to, and then we hit the left parenthesis. We read this one. Pointer to function expecting. Oh, okay. This is function expecting. Alright. To sanity check yourself while you are creating declaration. But where to put the next symbol and later parentheses are required. Some declarations look much more complicated than they are due to array size and argument is in prototype form. If you see okay, that's read as array with size 3. If you see char, okay, in that's read as function expecting and returning, okay. Function expecting, what is it? Char double, pointer char and double, right? And returning, we hit the right parenthesis, so we go to the left one. This one pointer and returning pointer, we hit the left parenthesis, I guess. So we go back to the right side pointer to array size 9 of array size 20 of in. Oh. It is quite possible to make a local declaration using this rule. What's local in C is necessary. It above had been. Okay. Oh, right. The function returning array of but only pointer that declaration is illegal. Oh, okay. Cannot return array. Alright, interesting. So this, what is it called? This parenthesis, like we have extra parenthesis here. I guess. Yep. Cannot have an array of function. Okay. Cannot have a function that returns a function. Cannot have a function that returns an array. To set to parents to find a pointer symbol on the left between this and square bracket right side symbol in order for the declaration to be legal. Okay, interesting. This can be a lot easier than the clockwise, I guess. But yeah, we will see. Right to left. Assignment and pointer. Now, how do you assign an in? It is also wrong. And the solution might be obvious. It is also wrong. Okay. We need to dereference first. Any direct assignment to a pointer will change the address in the variable. Any direct assignment, the address in the variable. Change the address in the variable, not the value at that address. Okay. In this example, the new value of VPTR, that is the new pointer in that variable, is 42. Okay. So with this assignment, we are actually changing the memory address. I guess that's valid, right? Let's check whether that is valid or not. Okay. Nope, it's not valid. Okay. At least when using GCC, right? any direct assignment to a pointer change the address in the variable. Okay. We don't know that this points to anything, so it probably doesn't. Trying to access this address will probably result in a segmentation violation. The seg fault, incidentally, compiler usually warn when we type like GCC is not actually a warning in my current version of GCC. I can forgot. I think we can do something like this in version 15. Okay. It become an error rather than warning. You must dereference it. Okay. Dereferencing. In this declaration, the declaration operator prefix asterisk, not to be confused with multiplication operator, right? Looking up the value that exists at an address. Okay, this is called a load operation. Oh, interesting. It's also like that in this prefix. Okay, look up the value that exists at the address. Okay, right. A load operation. It's also possible to write a reference expression to see where a reference expression is an L value that it can appear on the left side of an assignment. Right, I'm still not really sure what is L value and what is R value, you know. Here's a declaration of a tree in array. Okay, like this one, right? Not that we use the square bracket notation because we are declaring an array. Okay, array would be illegal here. Compiler would not accept us assigning the initializer to it. Is an extra big box, 3-inch worth of storage. Okay. One neat feature of C is that in most places when you use the name array again, you'll actually be using the pointer to its first element. Right? It's like this. This is called decaying. Oh, okay. The array decays to a pointer. Most uses of array are equivalent to if array had been declared as a pointer. There are of course cases that aren't equivalent. One is assigning to the name array by itself. Oh, that's illegal. Okay, so we cannot, let's say, do something like this and then putting the is it called? The number. Maybe I should commit this first, right? Git commit an example of relation between pointer and array. In this example, we explore about the pointer in an array, and also of the pointer represent in an array a pointer arithmetic and void pointer and function pointer. The pointer representation okay, the pointer representation in an array, a pointer arithmetic, okay. So this one is legal, right? Okay. Another is passing it to the size of operator. The result will be the total size of an array. Total size of the array, not the size of a pointer. Size of array using the array above would evaluate to in size n equal 4 times 3. Okay, this means that the size of integer is 4 bytes, and because we have 3 elements, we multiply the bytes, the size of integer in bytes, by 3, which results in 12. So this means the size of array, assuming array is like this, is actually 12 bytes. Remember, this is in bytes. Okay, this illustrates that you are really handling an array and not merely a pointer, right? In most use, however, array expression work just the same as pointer expression. So, okay, replace it. No, not integer overflow. Array in function parameter, right? We can also replace this with something like this, I guess. Let's find out. In function method playground. Okay. Right, it works. Array length. Array, okay. It works the same thing. That's the same as pointer expression. Expression work just the same as pointer expression. Let's say we want to pass an array to printf. You can, okay, when pass an array as an argument to a function, you really pass a pointer to the array's first element. So it decayed, or so we have this array, and then when we passing into a function as argument, we only have the first element passing into the function. So it decay, right? Decay to a pointer. Only give printf the pointer, not the whole array. Right? There's no way to print an array. It would need you to tell it to the type of what's in the array and how many elements there are. And put the format string and the list of argument would quickly get confusing. Right. Decaying is an implicit address of array equal well, what we found in the previous session, the value itself is the same, okay? So this is actually returning true, right? But the implication of this and this one is different. This one means that we get the address of array index 0, right? And this one we get the address of the entire array. This can be different when we are doing pointer arithmetic, something like that. In English, this read array, pointers to array, and pointer to the first element of array. The subscript operator has higher precedence than the address of operator, okay? But in CL3 expression mean the same thing, okay? They would not mean the same thing if array were actually a pointer variable, since the address of a pointer variable is different from the address inside of it, right? So basically, I think in this example, right, where is it? This one. Assuming we have the memory address like this one, 7 to 30 is actually the memory address of A, the A variable here, which store the character set, right? And then 8092 is actually the memory address of B. And then we are saving the memory address of A in B, which has memory address 8092, and then this one 10502 is the memory address of C. Okay, thus the middle expression would not be equal to the other two expressions, right? The two expressions are all equal only when array really is an array. Okay. Pointer arithmetic 1 not equal 4. How many do we have here? Okay, 2 minute indexing. Okay, where is it? The referencing this one. Say we want to print out all 3 elements of array, right? Array, okay. Right, like this one, using the postfix plus, and then this one, the third. Right, we are actually, what is it called? Moving the pointer itself, right? So when we are doing this is the second index, like 0, 1, and then this is the second one. It adds 1 to the variable, the same as variable plus equal 1. The postfix expression, rather than the prefix, this one, the expression evaluated to the value of array ptr before it was incremented. So we use the value of array ptr first, right? Basically we dereference this first, the array ptr, and then increment that later on. Okay. But what did we do with it here? Okay, I'm kind of curious. Increment pointer, okay, and the reference incremented address, okay. So this one basically we increment the pointer first, and then dereference the increment address. Alright. The type of a pointer matters the type. Then here is in when you add to or subtract for subtract from a pointer the amount by which we do that is multiplied by the size of the type of the pointer. In the case of our 3 increment, each one that you added multiplied by the size of n. Okay, of our 3 increments, each one that we add was multiplied by the size of n. By the way, the size void is illegal. Void pointer are incremented and decremented by 1 byte. Okay. Is void pointer always have 1 byte? I mean, from the previous session, someone said that char size might not be 1 byte if we have UTF-16, right? So this is kind of interesting. Void pointer are decrement by 1 byte. Talking about 1 equal 4. Remember that earlier ints are 4 byte on current Intel processor. Okay. I mean, my machine is INT1, so it also have 4 byte. So on a machine with such a processor, adding 1 or subtracting 1 from an in pointer change it by 4 bytes. Okay, programmer humor, right? The programmer humor indexing. Okay. What just happened? This happened. Well, you probably figured that out, but what does this have to do with pointers? Okay, there's another one of the secret of C, the subscript operator, the square bracket in array, square 0, right? Has nothing to do with arrays. That's what we learned previously. Oh sure, that is most common usage, but remember that in most contexts, array decay to pointers. This is one of them. That's a pointer you pass to the operator, not an array, right? So this one is also another form of dereferencing a pointer too. Repeat the R, right? Bend the brain a little, okay? Alright, this one. Here's the diagram. Okay, we are dereferencing what is it called? The memory address in this index, right? And then we get the address of the memory address itself. Array points to the first element of the array. Array ptr is set to address of array index 1 offset 1, I guess. maybe I should call it offset from now on. Right? So it points to the second element of the array. So array ptr, array ptr is equivalent to right. Array 2. Wait, what? Array ptr1. Oh, okay. Array ptr offset 1 is equivalent to array offset 2. Okay, array. Alright. This one is actually this one, 67. Okay. Also, you might notice that because the first element is size of in, right? Of in bytes wide, and in the second element is size of in bytes forward of the start of the array. So it is, well, we have, let's say we have the size of in as 4 byte, so it's actually like 4 byte and then another 4 byte, right? It's equivalent to, okay, the offset 1, right? The number added to or subtracted from is multiplied by the size of the pointer type. Like if, let's say, the integer pointer type for the array, I guess, for the array of integer, it would be like 4 byte, and so on. Structure and union. Okay, two of more interesting kind of type in C are get a structure type with struct keyword. Okay, the exact definition of this type are beyond the scope of this article. Okay, right. As far as I understand, struct is meant that we can create a new data type, I guess, and using that instead of the usual data type like char in, unsigned in, something like that. And union is quite interesting. I'm not sure if I have union. Oh, I have union playground. Okay, so it's basically, what is it called? We are using the same memory, but we can store different type of data in it. So the size of the union type, I guess, is actually the maximum size of the data type in this union. Like for example, this one, I think it is the same as float. Yeah, I'm not really sure. I cannot forget. Let's find out. Union background. Oh, the pointer one. Interesting. Right, the pointer of char one is the highest one because pointer in my machine is 8 bytes. Okay, interesting. There's a little bit of union. Each of those declaration inside the block is called a member. Unions have member too, but they are used differently. Accessing a member look like this. Struct foo. This is the variable name. Footnote size. Okay. I think we can put this in one line, like this one. Struct foo. My foo size equal size of struct foo. I think this one is equivalent to this expression, this two line. Okay. The expression my foo dot size access the member size of my foo. Right. You have a pointer to a structure. One way to do it. Okay. But there's better way for this purpose. The pointer to member operator. Right. The arrow symbol, I guess. Unfortunately, it doesn't look good with multiple indirection. Yes. Multiple indirection. Pascal does this much better. I don't really remember Pascal anymore. Is the reference operator is a postfix. But putting this complaint, she is a much better language. Okay, multiple indirection, right? Okay, right. This is equal to, where is it? Pointer to pointer, this one. But in this article we are using multiple indirection instead. Here are how the values of this pointer equate to each other. The referencing 3-star programmer. Alright. Once gets you an N equal to, okay. So we have this one, the outermost. This is pointer to pointer, which also points to another pointer. Right. We get the pointer to pointer in, right? Reversing this one twice, we get a pointer to in. Get in, right? Okay, this is the same. this one, right? Thrice. Thus the address of operator or ampersand can be thought as adding asterisk, increasing pointer level, as I call it, adding the asterisk. Okay. And the asterisk, arrow, and square bracket operator as removing asterisk. Okay, the layman term, right? But it is actually easier to understand this way, The address of operator adding asterisk and these three operator decreasing, removing the asterisk. Pointer and cons, right? We just take a look at this previously. It's a bit different when pointer involved. Right? This can be quite confusing, but this is actually the same. Have the same meaning. This is not the same. See how the cons after the pointer, right? In this one means that we have a cons of in. So the pointer points to the value integer constant. Or well, we can also use this one, integer constant or constant integer, right? So this is the type that the pointer points to. Is the keyword the points to. Okay. So the one that have the constant is actually the value that we are points to. And this one means that the constant is on the pointer itself, which point to the integer value. This one means that we can change the pointer, the memory address of the pointer, right? Basically, pointer is we are saving the memory address as a value. So we can change this value, this memory address value, this memory address as a value in this expression. But it needs to be a constant value. The memory address needs to have a constant value storing inside of it. And in this one, we cannot change the pointer value. It is the memory address, another memory address, right? So we cannot change the pointer in here. Okay. In the first example, the in cons, you cannot do k, right? Because this is basically we are dereferencing and trying to change the constant value, which is invalid, right? Or I guess we cannot do that. That's the word. Because it is constant, we are not supposed to change the constant value, right? And in the second example, the pointer itself is cons, right? So we can dereference the ptrp, right, and change the integer value storing in the memory address in the pointer p, ptrp, but we cannot do something like this, changing the pointer itself. Function pointer. Okay, this is. Guess this is the last one. Oh no, there is also string. Okay. Well, I guess let's save this for the next session. Right. Okay, so that's it for now. See you next time. Bye bye.